Before you blindly jump into using trigonometric substitution, you should have a quick glance to see if you can use u-substitution. Because if you can spot that you can use u-substitution, then you can save a lot of time rather than just blindly jump in and use trigonometric substitution. So let's look at these two here. In the previous video, we did this. We used trigonometric, but if you try to use u-substitution on this, it would be a nightmare. This one, if you use substitution on this, it will work. Let's compare the two. So looking at these two, hang on. Looking at these two, if you try to use substitution on this, it would be very difficult because okay, let's try it. Let u be this thing here. So let u be this thing here. Then du equals this. So dx equals this. Notice that you've got an x in here. So when you come to put this into the dx here, you see you would use these two. You would break up the x squared into these two, and then the x would cancel out with this one here. And then, well, this thing here would be u, but then you still got a block of x here. So you would need to translate this block of x. So you would need to go back to here and then rearrange it to make x a subject. So it would be u plus 4 and then square rooted equals x. So you would then put this block into here, and then it would become something really ugly. It would become something like it would become u plus 4, and then you've got your over square root u, and then you've got du over 2. This thing here is very difficult. It's really messy. It doesn't neatly cancel itself out. Now, if you look at this, let u be this thing here. So let u be this thing here. So du equals this thing here. So dx equals this thing here. So when you put this, so notice that dx, you've got an x at the bottom here. If you put this into the dx here, and then visualize this block here as being a block of x squared times a block of x. This dx here, this x here, will cancel out with this x here, and then you've got a nice neat x squared. If you go back to this, you can see, because this is not a nice neat x squared, you can easily translate it. So this would be hang on. So x squared equals hang on, let me think. Plus x squared minus u. X squared will become 1 minus u. So now you can put this into this thing here, because you've got an x squared here. It becomes nice and tidy. So it becomes a lot easier. It will become this. It will become 1 minus u, and then you've got square root. Remember, this is u here. Square root of u, and then your dx would be minus u du over 2 here. This thing here is actually easy to integrate. It would tidy itself up. It would be easy to integrate. Now, if you look at this is x to the power of 3. Let's look at the case where it's x to the power of 5. X to the power of 5. So now again, let this be u. So let this be u. Let this be u. So du equals this thing here. Dx equals this thing here. So if you put this into here, and then visualize this as a block of x, because you need to extract this block of x so that it will cancel out with this x here. It will cancel out this x here. Now you've got x squared, so you can easily translate it. So it will become something like this. It will become something like this. It will be easy to integrate. It may look ugly, but it will be easy to integrate. Whereas over here, you've got your x here. It will cancel out with one of the x here, and then here you've got an x left over. If you have an x squared, then it will be nice and neat. But then you've got this one x here. This thing here will become messy. So you've got to use trigonometric substitution, because this thing here it's nice and neat, because you've got this x squared here. this x here will cancel out with this x here, and then x squared, you can easily translate this x squared because this thing is easy to swap it over. So so here you should use u-substitution rather than trigonometric substitution. Here u-substitution would be messy, so you've got to use trigonometric substitution. Okay, so have a quick glance to try and spot that you can use u-substitution before you invest your time into using trigonometric substitution. I will give more examples in the next video. Okay.